As you see, we have the Samsung plasma TV. Yeah, I don't fix the plasmas a lot anymore. Yeah, it's made in 2008 and the model number is a PN42A450P1D. Anyway, let's look at it. We'll go from there. Yeah, I don't want to plug it before I can just quick check. There's a lot of dust. See, everywhere. Yeah, the plasma TVs is kind of some stuff is the same, some stuff is different. Main board is doing the same thing. LVDS cable is going to the time controlling. From the time controller is go to this one's is a X's. There is a 2X boards here, and there is YZ board. Plus there is the buffer, power supply. Yeah, just quick check for this old TV. All right. Okay. Yeah. So look like it's gonna be an easy thing to do. Hopefully. See this big capacitor is leaking over there, and is swollen. Hopefully that's what is the problem. Yeah, I'm not gonna test it. I'm just gonna go ahead and replace that capacitor. So the power supply is generating the voltages for the main board. Send the voltage to the timing chip on. Plus is make high voltages for the Y and Z board. Usually the plasmas, they have the problem in these voltages because there is a short in some of these buffer boards, Y or Z boards, like they shorted. In some cases we find the chip in the buffer board. I replaced them before, many of them before, like 10-15 years ago. All right, yeah, let's go with the easy stuff, then we go from there, hopefully. Look like these capacitors are bad too. If you look carefully over there, there is a gap, and they see like the capacitor swollen from the bottom. This one too. You see this one's? Sure. There is a gap in them. Right over there. Alright, let's take it. Yeah, I remove this swollen capacitor, and I find this big capacitor right here, like the one that I told you it was leaning like this. It wasn't like all the way in, and it was, you can see one pad is completely gone. So that pad is corroded from leaking. You can see the mark over there. And we have two capacitors. The pad is completely gone. So that's another way. The capacitor wasn't swollen from here, but it was leaking from the bottom. And you can tell because the capacitor is set like this. There is a gap between the capacitor and the board. Sometimes the gap could be just the capacitor didn't push it all the way when it was soldered. But when I smell the board, that's what they use inside the capacitor, the oil from the fish. Alright, let's check the other capacitors. We have one here. Okay, the positive side is right here. 0.5 is okay. So there is a capacitor here, small one. I think it's for the VCC. 0.8. That's a small capacitor. That's small capacitor is gonna be a little bit high resistance. Okay, 0.2, that's a little bit big, or 0.1, that's good. So we have more capacitors right there. Zero 0.6, that's good. I'm looking for the open capacitors. 1 ohm, must be a small. Yeah, that's a small. There is another one. Yeah, there is another one right here. Okay, what is that capacitor? This one right here is a 10 microfarad. Yeah, the between 10 and 1 microfarad, sometimes they give a open. It's kind of hard to check them. 47 ohm. This one right there. Oh, 47 microfarad. Yep. Yeah, I'm gonna just check the big ones. Cause the small ones usually they show the open. So here is one. This one is okay. There is a big capacitor right here. It's good. It's okay. Yep. Yeah, look like the output capacitors are good. So there is a big capacitor, huge one right here. Yep, that's okay. Another one, and this one. Yep, that's okay. So we have these 3 capacitors, 450, 220 microfarad, and 22 microfarad, 450. Yeah, this is the capacitor I find here in the board. Okay, this one is 270 microfarad, 450. It's gonna work for this one, 220. And we have exact the same, this one, 450, 22 microfarad. So we check them to be sure that's they are good. Of course, we need to discharge them. Even it's been sitting here for many years, but it's good to. Alright, 23 microfarad and 150 ohm. That's great. Yeah, this capacitor is better than the new ones of brands. This is KXG, and this one is, Nichicon. So this one is show is a 270 microfarad, but we may find like 230 or something. .240 microfarad, 100 ohm in the ESR. That's really good. The capacitor looks flat, brand new. Even is 10 years. Same thing, 246.0 ESR. Perfectly good capacitors. Okay, yeah, that one is such over there, good. Yeah, we pay attention to the polarity of the capacitor. If you put them in a wrong polarity, it's gonna cause the capacitor is gonna blow. Let's push the capacitor to the board. That's good. Thank you. Okay.
There's another UPS, but I don't know.
Big package?
No, they put paper on the door.
Okay.
That's stuff too.
Thank you, honey.
Yeah, I had other things to do, but come back here. See you later.
See you later, baby. All right. Yeah, so the fuse, it looks good. So let's go test it. Yeah, when you are testing the boards in the plasma, be sure you put all the screws before you put it to the power. Because any spark between the board and the metal, it may cause the other board to burn. It was a common problem in the Panasonic TVs. The screws get rusty under them, bad connection to the ground, and causing the boards, causing the components like and the Y and Z board, they cause them to burn. Hopefully that's all is need, because I don't want to put a lot of time in this TV. Let's plug it, the TV is going to work or it's going to blow. Yeah, we plug the TV to the power. The switch. I hear the click. Yeah, I hear the click in the power supply. Yeah, it's keep clicking. Yeah, it's keep clicking on and off. check the VS and VA. Yeah, we don't have no VA, no VS. 2.4 volt, the VA. VS 2.3 volt. VA, nothing. Okay, what we have here, let's say 3. Here is 5 volt. But the VA or VS 0 volt. So let's do another check. Let's disconnect the Y and Z boards, and if everything works good in the power board, we should see like we should see like quick VS 207, and is nothing. $14 the VS, nothing. Yeah, the power supply, it doesn't give the VA and VS. The fuses are good. The problem, you would put a lot of time in the power board, or even you get another power board for this TV, then you find the Y or Z board, or the buffer, or the plasma, the screen itself is bad. It's really yeah, sure, this Mosfet is not too blown, because if the bad Mosfet is just gonna blow the fuse. Yeah, the fuses are good. 5-volt fuse is good. Yep, the fuses are good. But we have no VA, VS. These two capacitors is for the PFC circuit, the circuit that's getting the voltages from 160 to almost 400 volt. Let's see over there. Yeah, it's go to 390. Yeah, that's the negative side of the capacitor. We can check it from there. And we can check some voltage. So this transformer is for the standby with this power manager IC. That's for the 5 volt. This transformer is for the 12 volt with this STR. This transformer is for the VA and VS with this switch in IC. So that's the output of this transformer and this diode. We have 5 volt. Oh, we're gonna check it from here. Yeah, 5 volt. The output of this transformer, you can see it here. So almost 13 volt, that's normal. But the output here is nothing, and the VAVS. So that's the circuit is not working. Okay, I disconnect the main board. We're going to have the 5 volt stable right here. No 12 volt because it's off. So we're going to need to jam PS on to the 5 volt and jam PS on to the VS. So 5 volt is here, 12 volt, it's not there. Yeah, we have 5 volt over there, but still. And we have another PS on right here. One, two, three, 4. So that one, maybe we need to check the 5 volt over there as well. Let's see, do we have 5 volt? No. No, power supply still not on. No. How much we have in the PS on? Okay, so we already have the PS on voltage. We need to short the PS on to the ground. Okay, got it. So the VS on, do we have the voltage? No. So what we need to do is short it, the PS on to the ground. We can disconnect this one, don't need it. So just to force the power board to turn on. And here if we go to the here we have 13 volts stable. But of course we are not going to have the VS. So the VS, we are going to need to short, to turn on the VS, we're going to need to short the VS on to the 5 volt. I did hear the relay, so that's the VS on. Nothing. No, no 12 volt. 5 volt is there. So yeah, as you did see, we did replace these 2 bad capacitors. We replaced this capacitor, but still we still have the same thing. I do have 5 volt, I do have 12 volt, but I don't have no VS, no VA. This is the transformer that's giving the VS and VA. Is switched by these 2 Mosfets, and I think this switching IC right here, maybe this one or this one right here. So we can see we have one, this is a small transformer, this is a 5 volt, this is for 12 volt, this one for the VA 207, and I think is a 50 something volt for the VA. And we have these 2 look like a transformer, but this is a 2 coil for PFC, the circuit, the step up circuit to get the voltage from 160 to 390. And we have a tiny transformer right here. The fuses are good. So likely this power manager for this transformer, maybe this IC is for the 12 volt, and this IC it's for the VA and VS. So that's the gauge of the VA and VS MOSFETs, this one and this one here. We have a diode, we have a jumper here that's going to this point. This gauge, this MOSFET gauge is go to this diode, then it's go to these points right here. And that point is this tiny transformer. So we have the primary coil right here, and we have 2 coils, for one for this MOSFET and one for this MOSFET. You can see the pins. Here is the primary coil, here is the secondary coil. So one here, one here. Alright, the engineer put this transformer in this circuit to isolate the IC from the MOSFET. So there is no physically connection between the gauge of these 2 MOSFETs to this IC. Or let's see, no, basically to this IC, because this 2 point right here, it's, you can see the traces, is go to this IC. That's switching the 12 volt as well. So this IC is giving the signal for the 12 volt and for the VA and VS. And the switching IC for the PFC, the step-up circuit. All right. Yeah, must be this IC is good, because we have the 12 volt and it's the same IC that's giving the signal to the 12 volt MOSFET, is giving the signal to the 2 MOSFET VA and VS. This is a smart design. They put a transformer right here, because any short, any high voltage in this area will not reach the IC. So let's check the MOSFETs. Alright, this one is good, it's open. This one here is a 0.3. That's not bad. From here to here is a 0.004. That's very low. Alright. to here is open, and to here is a 0.0 something. Yeah. So why we have that very low reading right here? And we have this lower reading in these Mosfets. We have to take the Mosfets. Alright, let's do it. Already discharged the capacitors in case. Okay, now this screw is it's hard to reach in this area. I see a seller on eBay selling this board for like over 200 bucks for an old plasma. Okay, no reading. 5, that's okay. So we have 0.5. That's low. No. Okay, this Mosfet is good. So this is an N channel. We put the black probe in the middle, and if we check here, we have 0.3. And if we give a charge to the gauge of the Mosfet, 0.09. And if we discharge it, like the black probe, we put it in the gauge to discharge it, it's back to 0.3. This is another way to test the Mosfet. So the same thing, this one. So we put the black probe in the source, 0.3. Oh, this is not good. So that's 0.3. But you can see here between the gauge and the drain is 0.00 something. That's not right. I think this Mosfet is good. You can see open. This Mosfet, it's bad. So we have a bad Mosfet. We're still finding bad parts in this board. So this one is 13N 50CF. N channel Mosfet is a 13M 500 volt. I don't have a Mosfet this size, but I do have a small Mosfet. This one is a 13A 60D. This is an N channel. Is a 13M 600 volt. This is 13M 500 volt. Even if it's big, but this Mosfet will do the same job as this one. This is 13 ampere. This is 13 ampere. Alright, let's check the place of the Mosfet. still have that 0.0 right here. Same thing. So we have between the gauge and the drain. But why? Okay. So that's the gauge. Is go to this diode, then it's go to this jumper. So the source, it's go right here, and we have a resistor over there. This resistor is a 1 kilo ohm. I think it's a 1 kilo ohm, this resistor, let's say. 10 ohm. Yeah. This resistor, 10 ohm. No, this resistor is a 10 ohm. Okay, I see. Yeah, this resistor is a 10 ohm. That's it's go from the gauge and it's go to this resistor. This is 1 kilo ohm, right? And yeah, so this trace is go to this resistor 10 kilo ohm, and it's go to the jumper, and it's gonna go to this jumper. It's go to the coil, so there is a coil right here. In this coil we should have a low ohm. Of course it's just a wire, so it's a 0 ohm in this coil, of course. So in these two jumpers it will be 0 ohm, of course. And here we have 0 ohm. That's normal. So between this point and this point it will be 0 ohm, right? Yes. And if you see this trace to the source, and to here it should be 0 ohm before these resistors and before this resistor, right here. It's the same we measure right here between these two. Is the same we measure between this one and the gate and the source. It's the same trace here. The same trace is going right here, and it's going all the way to that point, to here. So 0 ohm right here, of course. So when we measure between here, between the gate and the source, so let's just put it here for now, or we can put it here. We are going to find 10 ohm, because we are measuring this resistor. the diode is parallel with this resistor, but we can't measure it with this resistor is at 10 kilo ohm. So likely this is a normal reading, 10 ohm, yeah, because we are measuring this resistor. So same setup as this Mosfet right here, because it's connected to these two coils inside the transformer. So when the signal is come to this coil, it will transfer it to these coils right here. This is one, this is two. Alright, now how to use these two MOSFETs, these two small MOSFETs in the size, but is the same in the power. 13 amp, 13 amp. So I can solder the, yeah, I have to put the MOSFET right there, but let me put some grease. Or before that, let's solder this. So this is the bad MOSFET. I'm gonna cut the legs because I need them, and we use them for the other one. Sure the legs is not touching the metal. it was a two Mosfet the same, it's better you replace them at the same time, because one of them is going to have a different speed even if they have the same part number, but it's better you replace both at the same time. You know, the component by the age is changing the speed, changing the many things. So the leg is away. So if this Mosfet has a metal plate like this one, we are going to need this thing, because there is no connection between that metal and this heatsink. But this one is a plastic, is okay. Yeah, I did check the replacement Mosfets, no short in them. So that's the, okay, here we have 0.4 or something. 0.4, it's good. It's good. It's good, it's good. Alright, everything is looks okay. Let's go put it in the TV and test it.
So we put all the screws and with the switch to be sure it's loose.
Okay, let's get the multimeter ready. We put this probe in the ground. And we are going to connect just the main board and the timing board. This one's here. So we don't need to connect the X and Y board. So let's plug it to the power. We turn on the power switch. I hear the click, so we be careful. I hear the sound. The TV is still on. That's good. 207. It's fixed. It's fixed. The TV turns on and we have 207. Yeah, the Mosfets are not hot, or they're just like normal. We give it a minute, then we connect the two boards. Because sometime when we connect this one, if there is any spark, may burn the Mosfets in this ones. Let's do it. What happened here? Okay. No spark. Okay, good. Let's power it again, and we be careful if we see any smokes. We are going to turn off the switch. It powers on. I hear the sound. The TV is staying on. So how much we have? The VS, we have 0 volt. Why? No, we have 207. The probes of the multimeter wasn't connecting good. Here, 207, the VA 54. Exactly as it show here. 207, 54. If we have any different voltage, like if it is this one is a 52 or 53, we can adjust it from this potentiometer. Alright, let's flip the TV and see if we have any picture. Yep, the TV is on. We have the picture working fine. So this is all for this video. Thank you for watching.